Hello, today we're going to talk about Chapter 1, Earth, the Water Planet. We're going to talk about the distribution of water throughout the Earth, as well as water's unique properties, and a little bit about the water cycle. Living things on this Earth depend quite a bit on water. In fact, when we're looking for life on other planets, the first thing that we look for is there water there? We depend on water for agricultural, industry, transportation, recreation, and cells rely on water for growth and reproduction and lots of other processes. The distribution of Earth's water is shown here in these bar charts here. So here the first bar shows us that oceans make up most of the Earth's water. So most of the Earth's water is salt water. A small percentage, about 2.5%, is actually fresh water. Of that fresh water, most of it is bound in glaciers and ice caps. Most of it is frozen. And then also quite a bit of it is groundwater. So it's only this very small amount here at the top that is surface water and other fresh water. And of that, at any given time, lots of it is frozen throughout the world. So there's a very small amount of water that we rely on to use in our daily lives. This is a great picture that shows if we took all of the water on Earth and made it into a sphere, so a three-dimensional like a ball, it would be this size right here. And this is really nice at showing us that water is really just a thin film over the skin of the Earth. So it is, we know that it's very, very deep, but compared to the size of the Earth, there's really not that much water on the Earth. So if we made it into a sphere, it would fit right here in the United States. So it gives us a really good picture of how much water exists on the Earth. Now let's talk a little bit about the unique structure of water. A water molecule, H2O, means that it's made up of 3 atoms. The 2 goes with the H, the hydrogen, so that means there are 2 atoms of hydrogen and 1 atom of oxygen bonded together. And often the molecule is called the Mickey Mouse molecule because it kind of looks like this with the bigger oxygen molecule and in the center and then 2 smaller hydrogen molecules attached to it. Water molecules form hydrogen bonds between each other. And this is because in a water molecule, the slightly negative oxygen atom kind of goes to one end, and the positive hydrogen atoms move to the other end. So this causes water to be polar, which means that one end of it is slightly negative and the other end of it is slightly positive. Now overall, the water molecule has a neutral charge because it does have the same number of positive protons and negative electrons. But because the negative ones kind of gear towards this side and the positive ones this side, then we call it polar. And a hydrogen bond forms when the positive end is attracted to the negative end of another water molecule. One hydrogen bond might be weak, but when you have many hydrogen bonds, they become very, very strong. And this hydrogen bond and the polarity of water is responsible for many of its unique properties. Now let's take a look at a brain pop explaining some of these unique properties.
Dear Tim and Moby, how do you make water? From Emily. In its pure form, water is a chemical compound made from 2 different elements, hydrogen and oxygen. The positively charged hydrogen atoms bond to the negatively charged oxygen atom to form H2O. Each water molecule ends up with a slight negative charge on one side and a positive charge on the other. This makes water kind of sticky. Water's stickiness is what makes the molecules clump together into round drops. It's also the reason for the skin or surface tension that forms on the surface of water. Water is known as the universal solvent, which means it's good at dissolving just about anything. By the time water gets to us, it's picked up minerals and chemicals from just about anything it's passed through. These extra substances can change the properties of the water. For example, the salt dissolved in seawater lowers the ocean's freezing point. Water can also be hard or soft. Not that kind of hard. Hard water also reacts strangely with soap, making a weird scum that's hard to rinse off. Hard water has calcium, magnesium, and other metals dissolved in it. It can deposit these metals on pots and pans or in the sink. Soft water is water that is low or lacking in these same minerals. Well, actually, we're lucky that water reacts with so many things. Its versatility allows for the many chemical reactions vital to life. All life on Earth depends on liquid water in some form or another. It's the main ingredient of our blood, fills our cells, and it makes up about 65% of our body weight. And liquid water is rare in our solar system, except on Earth. Water covers over 70% of our planet's surface. And without all that water, we probably wouldn't even be here. I love water. One of these days, Moby.
Water has many properties that make it unique and a very special substance on the Earth. You can see many of the properties here that we're about to talk about. And the first one is cohesion. And cohesion, it refers to the attraction of water molecules to each other. And water clings to other water molecules because of the polarity and the hydrogen bond that forms between them. Surface tension is a measure of the force necessary to break a liquid, and so we say that water has a very high surface tension because of the cohesion. Surface tension can also be thought of as the tightness across the surface of the water, and again, this is caused by those polar molecules pulling on each other and being attracted to each other. And so often we see water having a curved shape at the top, and you guys might remember this from our lab at the beginning of the year with the number of drops of water on a penny, and how instead of a flat surface, the water had a bubbled up surface. Adhesion is another property, and this refers to the attraction of water to other substances, not to itself, but to other things. And we see this in the way that water sticks to other things. It's adhesive to any substance with which it can form hydrogen bonds. So like in the picture we see here, we see water droplets clinging onto a plant. Adhesion also causes water to stick to things like spider webs and form spheres and hold on to plant leaves. Sometimes students have a hard time understanding the difference between cohesion and adhesion. So this is a really good drawing to put into your notes. So we see here that cohesion is water's attraction to itself or to other water molecules, and adhesion is the attraction of water to other substances. Because water has these adhesion and cohesion properties, then we also see something called capillary action. And this is water's ability to kind of climb up through a substance. So think about a straw. When you suck water through a straw, it has no problem moving up through the straw, and that's because it clings to itself and it clings to the straw. And this is also how waters are able to move up from the roots of trees, up through the trunks of trees, and out to the leaves. We also see capillary action. If you've ever done a little experiment maybe in elementary school where you take a flower or you take celery and put it into colored water, and eventually you see that colored water being sucked up through the celery, and you can see the leaves here are colored. Water is considered the universal solvent, and this is because due to the fact that water is polar, it has those charged ends, and they attract the molecules of other polar substances. And so they're able to pull apart other molecules and dissolve them in water. And water dissolves more substances than any other liquid, which is why it's called the universal solvent. So wherever water goes, as we learn more about water in Chapter 2, we're going to watch it take along valuable chemicals and minerals and nutrients with it. The specific heat is the amount of heat needed to raise or lower 1 gram of a substance, not just water, but 1 gram of any substance, 1 degree Celsius. Water resists temperature change, both for heating and for cooling, so we say that water has a high specific heat. It can absorb or release large amounts of energy with little change in the actual temperature. This has a lot of impacts on the environment of the Earth. One impact would be that if we have a large body of water, so think about Lake Michigan here, it can absorb a large amount of heat from the sun in the daytime and during the summer, and it only warms a few degrees. So think about Lake Michigan and how long it really takes, even once the snow is melted, for that water to be swimmable. I mean, sometimes it's the end of June before you can really swim comfortably in Lake Michigan. At night and during the winter then, that warm water will warm the cooler air above it, which is why we have the lake effect snow, because that warm lake is warming up the cooler air above it and causing precipitation. So anywhere that's near oceans, any coastal areas, they have a more stable temperature than inland areas, and that's because the ocean regulates the temperature for them. So they don't see the same temperature swings that we do. So even out in Portland and Seattle, in areas that are further north in latitude than we are, they actually have more of a mild winter and more of a mild summer than we do because the ocean is regulating their temperature. You've probably already learned in some of your classes about changing states of matter from solid to liquid to gas, but there are certain terms that we use that are specific to water. So when water goes from a solid to a liquid, we say that's melting. When it goes from a liquid to a gas, we say that's boiling or evaporation. When it goes from a gas to a liquid, it's condensation, and then a liquid to a solid is freezing. Another unique property of water is that when it's in its solid form, it is less dense than it is as a liquid. And that's not true for many substances. And this is because liquid water has these hydrogen bonds that are constantly being broken and reformed. So frozen water actually has a crystal-like lattice structure whereby the molecules are set at fixed distances. So ice ends up being less dense than water. So if we look over here, you've seen a liquid, they're actually a little more free to move around, and here in a solid we have that set pattern. So which one of these would be ice and which one would be water? Well, if you said the one on the right is ice, you'd be correct because it has that set lattice structure. So oceans and lakes don't often freeze solid, and that's because ice floats. So that layer of ice on the top actually kind of protects and insulates the water on the bottom. And water also expands as it solidifies, and so it freezes from the top down. So often we still see organisms that can live in the water underneath the ice during the winter. Water also has a high heat of vaporization, and this is the amount of energy to convert 1 gram of a substance from a liquid to a gas now. So in order for water to evaporate, those hydrogen bonds have to be broken. And remember, those hydrogen bonds are very strong. As water evaporates, it takes a lot of heat with it. Because it has a very high heat of vaporization. It takes a lot of energy to change water from a liquid to a gas. Its heat of vaporization is 540 calories per gram, and so that means that each little gram of water has to gain 540 calories, not to change temperature. This is once the temperature has reached 100 degrees, but to make it change states from a liquid to a gas. So it ends up removing a lot of heat with it. This is just a nice little picture of the water cycle, and this is section 3 in your book. And I know that you guys have studied the water cycle before, but we're going to study it in class a little more in depth because I hope that you see some terms on here that you're not quite familiar with. For example, evapotranspiration, sublimation, and desublimation. Those might be new terms for you, so we are going to cover those in class a little more in depth. So thank you for watching the video today, and hopefully you have a page full of notes to help you remember some of these topics.